All right. Hello, everyone. I'm Alfred Neumayer. I'm presenting to you today a little bit about Ubuntu Touch. What is it and why should you care? Clicker doesn't want to work right now. Oh, no, there it is. I'm going to talk about a little bit of an introduction. I'm going to go through the history of the project, where it started and where it went. I'm going to talk about a little bit of the technology, and then I'm going to introduce you to a little side thing about app development and porting, should you be interested in getting this on your own phone. So, introduction. Let's get to the why should you care part first. The infamous mobile OS duopoly that we are all, I would assume that everyone here is very unhappy about Android and iOS being there, to the point where they are. Android started out as an operating system that was very open, close to open, not in the sense of open input from the community on how to develop it, but at least it was open source and released to the public. And iOS, of course, the most proprietary thing that there is in the mobile space. It's big tech and it's proprietary, and we need something better. So let's meet Ubuntu Touch. It's a free and mobile operating system that is provided to you by the community. We don't spy on you, and we don't target ads on you. So those alone are arguments to be made for an operating system that caters towards regular average Joe users. And we don't stop there, because Ubuntu Touch has its own set of features that make it stand out from the rest of the crowd. And we call that convergence. So what is convergence? Convergence is the cross-form factor UX that you can get from a phone, from a tablet, from a laptop, and from a desktop. So I'm going to go through this later on. So what we do have is an immutable file system. Ubuntu Touch started as a project that very early on wanted to compete with Android and iOS, because those were immutable as well. And it wouldn't be fair to release something to users that would break easily due to installing your updates on the phone in the rootfs. And for that matter, we have a selective writable path mechanism. So we have an immutable rootfs, and then selectively we copy over files from the rootfs to a user data partition, which can be modified, and we just bind mount them over so that it looks like it's all in one spot. We have the Open Store as the app store, as the de facto standard app store for Ubuntu Touch, where you can get your applications that are mobile friendly, but also convergent, so that they work across all the different form factors that we support. We support Debian packages via Libertine, which is not a container, but a chroot with a little bit of extra sauce. Libertine basically just sets up a chroot for you, and you can modify it and configure it from the system settings application. And in 2404, we also support snaps, should you be interested in those, which is handy for running your LXD containers. So you can have fully functioning LXD containers on a phone and connect it to a docking station. And it also supports running Android apps via Waydroid, should you be relying on any application that you cannot get easily from the Open Store or otherwise. This is what it looks like. You can see the lock screen, you can see the multitasking overview. the way that it renders your list of installed applications, and the top are indicators. A lot of work was put into it to support what is already out there, because actually it's a continuation of the Unity 7 efforts by Canonical. And Unity 7 and Unity 8, as you can see here, the convergence thing, they tried to provide something that is working across a multiple set of form factors. The applications adapt to a running system, similar to responsive design, but it's a little bit more than that. And we have seamless switching between devices. So the application that you run on the phone should be familiar on a phone, but it also should run on a tablet and be familiar to a tablet user experience. And also, what we tried to do, but we had to cancel in the last minute, was running a full desktop experience off of the phone. So this is the Fairphone 5. It has video out capabilities. And connected to a docking station, you can provide a full desktop experience and use it like a regular computer with your Office applications, with your mail client, etc. This is what it looks like when in windowed mode. You can see the application, the system settings, the applications, they all adapt to the scenario that they're running in. Actually, in the source code of the shell, we call this a usage scenario, where you run it on a phone, where you run it on a tablet, and you run it on a desktop. It all adapts seamlessly. So let's go through the history of the project. It was announced in 2013 by Mark Shuttleworth in his infamous video where they did the Ubuntu phone industry proposition. It was called Ubuntu for phones and tablets back then. And the shell was Unity 8. The shell, the desktop shell that you can see, is Unity 8. It was a continuation of the Unity 7 efforts, which was X11 only, was also from a technical perspective not feasible to be continued and dragged on into the future, because it was lacking and was limited in the way that you can adapt it and make it work properly. The initial focus was on developing markets, so that developing markets would have the ability to connect to the internet using their smartphones and communicate with other people across the globe. The first glimpse was actually on the Samsung Galaxy Nexus, and back then Android, we're going to go into the Android and Ubuntu Touch relationship later, but back then it was Android running as the host and Ubuntu running as a container inside of that host. And soon after, they decided to re-architect a little bit of that. They actually switched it around so that Ubuntu Touch is the host. It's the first process that gets started is Upstart, or nowadays Systemd, and it runs a stripped Android in a container, which didn't have a name back then, but nowadays we call this Halium, which I'm also going to go into later. Then the UBports community starts. It was founded by my friend Marius Gripsgaard in 2015. And the initial focus was to provide Ubuntu Touch to more Android-based devices. Initially, it was for the OnePlus One as the premier example device, but there was also the Nexus 5 and others, which grew out of that and ensured that there was a good user experience with Ubuntu running on a phone. 2016, fast forward to 2016, we have 6 devices sold with Ubuntu Touch pre-installed, which you can see here. The BQ Aquarius, which used to be a Spanish manufacturer. The Meizu, devices, which are Chinese. And you can see the different phones are the first ones, the first 4 ones, and the Aquarius M10 HD and M10F HD were tablets. And those tablets actually sold with the ability to run GIMP pre-installed on it, were demoed basically at the Mobile World Congress in back then, to showcase the capabilities of the convergence story, so that you can use your GIMP, your LibreOffice, whatever, on a tablet when you're on the go, when it's connected to a keyboard and mouse. And next up, the worst day for me compared to in the Ubuntu sphere was when I read the news that Canonical discontinued Ubuntu Touch and Unity 8 in 2017. But that didn't stop Marius from dragging it on and keep working on it, because he decided to take it over. So Ubiports, as the community, took over the development of Ubuntu Touch and continues working on it. The Ubiports Foundation, as a legal body, was founded in 2019. It's a foundation in accordance with German law. So we're running after, we're running with the legalities of Berlin. And in the meantime, what we also did was rebranding Unity 8 to Lomiri in 2020. We did this because every now and then people were coming into our Telegram groups and asking us for support about the Unity game engine, which was annoying. And this also eased the tensions of importing Unity into other distributions, because people were very hesitant on, or distro developers were very hesitant on including Unity 7 or Unity 8 into the respective repositories, and renaming it to Lomiri and making it as generic as possible eased the burden for many people, so that we now have it in Debian, we have it in Ubuntu, in the desktop Ubuntu, so it gets synced from Debian over to Ubuntu. We have it on Arch Linux. I've seen it on Arch Linux. There's also something for Fedora, and hopefully more in the future. Fast forward to 2025. We have partnerships with hardware manufacturers. So there are Volla, Pine64, and Fairphone. The first 2 have shipped devices with Ubuntu Touch pre-installed, and Fairphone is sort of a relationship where we can benefit off of the Fairphone expertise and legalities to implement stuff like voice over LTE, for example, for the Qualcomm devices. So the technology is next up. Something that we do on Ubuntu Touch on Android-based devices is using libhybris, which is a project started by an ex-Yolla employee. And it allows loading Android libraries into a GNU/Linux process. It's not injecting the thing out of nowhere. It's basically going the regular route of loading a library. And we do have wrappers for libegl, for libglesv2, so that we get access to the graphics stack, so that you can render stuff on the screen. And then we have compatibility layers, what we call them, for accessing stuff like the camera, for accessing multimedia, and various other Android C++ classes from GNU/Linux. So we basically wrap C++ classes from Android inside of those libraries with C linkage, so that you can access those functionalities from a GNU/Linux environment. Next up is Halium. Halium is the hardware abstraction layer that we use for Android devices. This is what the relationship between Android and Ubuntu Touch on Android-based devices is looking like. Halium is basically a container which runs the Android blobs as if it was running Android. Only the C++ and C bits, no Java at all. And usually we use this on Android devices, but we don't use it on a PinePhone because the PinePhone or other mainline devices are mainline devices which we can use without any of those weird abstractions. And which means Ubuntu Touch is very flexible to work both on Android devices and regular mainline devices. This is what it looks like. We have the Android Linux kernel down below. Then we have the system running at the top. And we standardized on using systemd for PID 1 so that the LXC containers get started from systemd. We also have those compatibility symlinks, system, vendor, and nowadays also ODM, which are in the rootfs side. So when libhybris loads the GLES driver, it actually needs to look it up in /system/lib64. We need this. It basically, for some people, it might look like polluting the rootfs, but it's sadly a necessary evil that we have to deal with. And then the compositor and display server on top. Lumiri is what we renamed Unity 8 to. It's the convergent desktop shell. It switches the appearance based on usage scenario, and it's written in C++ with Qt, QML, and JavaScript. JavaScript is only used for those pieces where performance is not critical. Most of the things, actually, I ran Lumiri with the interpreter mode only, without the just-in-time compiler, and the performance was almost the same. Because the rendering is not happening through JavaScript, it's happening through C++. And Qt and QML integrate this very well. QML also allows us to have a very simple way of describing the user interface in a markup language. If you're coming from a web developer's background, needs a little bit of getting used to, but you'll be surprised how quickly you can get something running very quickly and easily on this desktop stack that we have. Then we have Mir and QtMir. So Mir is a display server library. Mir used to ship its own client protocol, which caused a lot of confusion and anger in the community around, or in the communities that are not specific to Ubuntu, because it was a competitor to Wayland. And that is because Wayland was not at the spot where it needed to be for Canonical to release a workable phone in time. So they had to develop their own display server with their own protocol. But nowadays, it's a Wayland compositor. The Mir client protocol has been dropped, which is a bummer for us, because we still rely on a few features on it. And with X-Wayland, we basically, on Ubuntu Touch right now on 24.04, support 3 protocols for applications to render stuff on the screen. QtMir takes whatever Mir gives it and displays it in the Qt scene graph so that it gets injected into or added to the QML contents, and it powers the Lumiri shell. This works with Mesa and KMS and other platform plugins, like, for example, the Mir Android platform, which we need on the Android-based devices to integrate Android drivers into the Mir compositor, so that it talks to Hardware Composer, which runs inside of this Halium container, And every device on Ubuntu Touch is hardware accelerated by default. You can't get it with software rendering in any way, shape, or form usually. And it supports external monitors because the Fairphone 5 has video out capabilities and you can just connect it. Then there is EtherCast. We don't only support a wired desktop scenario, we also support it wirelessly through Miracast. And for that we use EtherCast. It basically streams an H.264 virtual screencast over Miracast to a display adapter and integrates with the Android multimedia framework. So those C++ classes that I talked about earlier, those are getting used here so that the video encoder of on the Halium side gets triggered, which results in basically with two processes running at 15% each in top, which means it's very low on usage, so 15% from one CPU core, and the performance reaches 60 frames per second easily. This is what it looks like when you connect it over. You have the TV in the back, you have the phone in the front, and the phone displays a virtual touchpad. When you move your mouse pointer to a text entry field, it pops open a keyboard so that you can enter your text there, and when you unfocus that, it disappears again. So it's tightly integrated. It's all part of the shell and of the shell process and works seamlessly. Then we have Qt. We rely on Qt for applications and the operating system. Right now, status quo, we are using Qt 5 with Lumiri UI Toolkit 1.3. This is what we have been shipping for the longest time, and right now we're in the process of upgrading everything to Qt 6, which will be available for the browser that we're working on first, because the web browser that we use relies on Qt 6 web engine, or Qt web engine, and on Qt 5 it's an old Chromium base. It's basically Chromium 78, which is old and unsupported, and we only get a little bit of security fixes from the Debian side into it, but this is not that's not a path forward. So we have to get our crap together and get stuff done so that Qt 6 web engine also works properly. We have an initial demo on the Open Store, which you can download, but it's not finished yet. Then the telephony stack. We use Ophono as compared to Modem Manager. This powers the modem using plugins, which are used to access the Halium side real interface and the voice over LTE services. We use that. We do that through Binder nowadays. Back in the day with Android 5.1 and 7.1, those used to be a socket. Nowadays we use Binder, the IPC mechanism of Android, because if we run on Android devices and everything expects Binder, we might as well use that. And that allows for mobile connectivity and telephony to work properly with the proprietary services that are provided by the vendor blobs. We have the telephony service, which maintains state over incoming and outgoing calls. So it connects to Pulse Audio so that it can provide audio to it, and should Pulse Audio crash, the telephony service nowadays registers that and realizes that and acts accordingly. And yeah. Then we have telepathy Ophono, which bridges Ophono and telepathy for stuff like, if you know telepathy, it used to be used for chat applications on GNU/Linux, and this basically bridges the gap between Ophono and telepathy so that SMS are properly used. For audio needs, we use Pulse Audio, where we also rely on the vendor blobs. We load those into the process, and the Pulse Audio module's Droid plugin creates the Pulse Audio sinks and sources, so that access to the hardware wired inputs and outputs is done properly. It switches over the profiles when an incoming call is coming, and when you take a call, it switches over the hardware wired pathways through profiles that are pre-selected or predefined, and that means that you cannot use, for example, multimedia while having a call at the same time. Pipewire is a dream for now, but we hope to get something off the ground someday. But for now, it's just not there yet, and I think we're not the only ones. Also, Sailfish OS seem to have no particular interest in providing something via Pipewire at the moment. So that's something for the future. Multimedia. The hardware accelerated video decoding on the Halium side, as I mentioned earlier. Those are video decoders, OMX and codec 2 encoders and decoders, which we integrate using GStreamer or a GStreamer plugin called GST Hybris. This allows us to access the vendor-provided functionality for video decoding, and we take it a step further for playing back music on the phone or video on the phone with MediaHub. So due to the way that Android's encoders work, we are able to play video back out of process instead of in process. So out of process means we have MediaHub running as the service that plays back the video, and it sends the frame over to the client application, where you can have a video player. The video player renders the content properly, but it's actually played back by MediaHub. This allows us to have music applications being paused when they're in the background, because we're very keen on saving battery, and we pause applications whenever they are out of focus. In every scenario, you can selectively disable that functionality per app, but regularly we do playback using MediaHub in that way. Then there is file system encryption, which has recently landed in 2404-1.0. It's not full disk encryption, it's FS-Crypt, which is a Google technology. We only encrypt the home partition or the home directory because of the operating system and user data split. So the rootfs stays read-only. The user data is separately available, and in the user data partition there's the home directory. We take the PIN and password from the user, set up the home directory, and then migrate over contents from the unencrypted storage to encrypted storage. If you just recently get a phone and you set it up immediately, it's going to be like that. And that allows us to have a very great user experience, because when you boot up the phone, you don't get an out-of-place looking on-screen keyboard. You get the real keyboard that is part of Ubuntu Touch. And you enter your PIN using that in the greeter in LightDM. And then it decrypts the home directory and spawns a real session. This provides a way better user experience than having an SDL-based keyboard in the initRMFS, because the initRMFS is also very cluttered already for the functionality of providing this user data split. So let's go into app development. I noticed I'm going through the presentation very quickly. I expected it to be not that fast, but let's see what happens. Clickable is our tool for creating applications on Ubuntu Touch. It's an all-in-one tool chain, so it provides compilers for C and C++, for Rust, for Go, everything in the Docker container. It also includes an IDE, which you can just start via starting clickable space IDE from the terminal. It starts Qt Creator, and Qt Creator is very tightly integrated with the QML workflow so that you can get autocomplete and whatever you expect. And you can also deploy the applications to the phone, or you can test run them on the desktop so that the desktop acts as if it was an Ubuntu device and you just have a window and you can play around with your applications there. What we also do, because OpenStore is very keen on providing a secure environment, because applications are confined using AppArmor, that applications get put through a review process. It's an automated process for confined applications. Unconfined applications cannot be released as easily. They need to be reviewed by the OpenStore team. Unconfined means applications that have access to the full system, that can access any socket, that can access any file on the file system. And for confined applications, those releases get pushed out to users immediately. Yeah. We recommend a few toolkits here. You might see there is no GTK, and that is because nobody has bothered bringing GTK applications to Ubuntu Touch yet. I would like to see some of them happening on Ubuntu Touch, but right now there's just nobody interested. If you're interested, get in touch with me and I can help you out. So we have the Lumira UI toolkit, which is the Ubuntu Touch experience as one expects from the phone and from the tablet. And it's great for Ubuntu Touch only apps. Now, should you be a Qt developer or QML developer and want something that works across multiple platforms, you're best served with the Qt Quick Controls 2, which is the toolkit that came out of Qt, the Qt company. And we have a theming package pre-installed in the rootfs so that the applications look similar enough to a Lumira UI toolkit environment. Actually, some applications mix and match those components, because some components are available in Lumira UI toolkit, but not in Qt Quick Controls, and vice versa. And we also have SDL, which is very often used in games. It works using Wayland. If you want to run it on Mir client, the old protocol, you can still patch up SDL with, or use an old version of SDL that has those protocol support bits in there. But regularly we just recommend using Wayland, because Wayland works on the phone, it works on the tablet, and why waste effort, right? Now this last point here, porting. Porting nowadays is very easy to do. Back then it used to require creating your own system image and modifying and putting all the proprietary blobs in there. Due to the Project Treble of Android, we are now able to use and reuse the proprietary blobs that are installed in a separate partition. So everything that is proprietary on Ubuntu Touch is in its separate partition, and we just use that. And nowadays you only have to patch your kernel and recompile it. Very important, the source code needs to be available, so don't get a smartphone without kernel sources available, which sadly still happens nowadays. You need to enable AppArmor and namespacing features app armor specifically for the confinement model, and namespacing so that the Halium container works properly. Then you provide configuration files using overlays that get pulled down from the system image server. And we do this for Ophono configuration, we do this for Pulse Audio, and maybe also other device-specific hacks that need to be put there. For example, turning on the Wi-Fi adapter on MediaTek devices, that's sometimes requiring writing to a temporary file or to a device node. And the Halium image itself is not something that you build yourself anymore. It's provided by the UbiPorts community, by the UbiPorts CI, because of Project Treble. It's built on GitLab CI, so we fetch the generic Halium build tools. It builds your port. It might take 1 hour or 2 hours, depending on the runner that it's running on. And then it hosts it on the GitLab CI, which gets pulled from the system image server, which is our OTA service. So over-the-air updates are usually done using system image. And then it gets hosted on UbiPorts infrastructure for OTA updates to be hosted to people out there. And that is about it. So thank you.
So questions?
Thank you. Hi. I bought a Volaphone, not Voda, 2 years ago, 3. I wanted, to escape from the Google madness.
Yeah.
And I, turned it on, and I was really confused by the Volaphone user experience. So I'm a Linux user. I said to myself, okay, I'll go and try Ubuntu Touch. And I ported, it was easy. And then I was even more confused by the user interface. How do you bridge that gap for, let's say, the normal users that use Android to start using Ubuntu and not to be entirely confused by what they want to do with their phone?
Well, so for Ubuntu Touch, it's a clear mission statement for us that we want to provide a user experience that is for average Joe users, not for hardcore nerds like you and me, but we want to provide something that works for regular average Joe users that just want a phone that works. And we make trade-offs there. For example, Libertine in the system settings is something very nerdy, very geeky. Because installing a deb package is not something that I expect a regular user to do. And also the UI, the user experience, is based off of user testing back in the day at Canonical, where they user tested it and made notes about the user experience. Also, it was very design driven. Which you can sometimes see is not the best idea. For example, for the multi-display support, when you have 2 monitors connected, you don't get to move over a window from one screen to another. You have to go to the overview and then drag it into the workspace that you want to have it. We are certainly not optimal in that scenario, in that sense, but for the phone, at least, I would guess that should you get used to the gesture system, the edge swipes from the left and the right, when you get used to that, the phone should be okay-ish enough for you to use it. But we're certainly lacking in the desktop department at the moment, which we are still working on.
Hey, I'd like to ask, how do you approach the reliance on Android? Is it a blessing or is it a curse, both from like ideological and technical perspective, especially with like the recent Android closed sourcing we've been seeing?
How that affects us, you mean?
Well, how it affects us, and both how you think about it. How do you approach it personally? Like, do you like it? Do you hate it?
I personally am not very fond of the way that Google is handling things right now. Simply because For Android-only users, for those who rely on Android, it's disrespect to those who are aware of what used to be there and what we are losing. And for Ubuntu Touch, we are losing something also because should this closing down of Android continue on and we would not be able to modify the Halium components anymore, which is a fork of Android, basically, right? Should we not be able to modify the Halium container anymore to support Android-based devices on Ubuntu Touch, then we're in big trouble. And right now, it seems like we would have to figure out a way to deal with that, either by contacting them, by saying, hey, we're the competitor, don't screw us over. But I have no answers on how to approach this at the moment.
So if there are no other questions, then thank you. And if you have some other questions, Alfred will be probably on the Ubuntu stand.
Yes,
Ubuntu
exactly.
Wood. So feel free to go to him and ask him. So thank you.